Well, hello. It's good Saturday morning. I'm sitting here filming your lesson for the week. This is the Monday lesson. I hope for you guys that played football last night in the scrimmage, hope you did well. Didn't get a chance to get out there, but I'll talk to you about it on Monday. And everybody else, I hope you're having a good weekend. So here we go. We're going to build on the order of operations that we talked about in the first section. So this is called 1.3, Solving Equations. And our goal, like I just said, is to build off of PEMDAS and some ideas of equality within an equation. So there's a couple definitions I'd like you to have. One is variable, and the second is equation. So the variable states that it is a letter which represents an unknown value. It can be any letter out there. Sometimes we even use symbols for variables. And equation is a math sentence that states that two expressions are equal. So we talked about expressions last section. If we actually set two expressions equal to each other, we have created an equation. So it's pretty simple how they work together. And an expression can be just simply one term, or it can be a multitude of terms. I've got a few things on the bottom here on the steps to solving. What we need to do first is simplify each side of the equation. So make sure that you combine like terms, use your distributive property, things like that on each side of your equal sign. Secondly, if you'll move variables to one side or the other, so sometimes you may have a common variable on either side of the equal sign, you need to get them together, and we'll see an example like that today. And then number 3, isolate your variable. So once you get your variables together on one side, you may have some other garbage, numbers or whatever on that same side. So get those to the opposite. And lastly, check your work once you've solved. Okay? It's important. I don't require you to write that out, but it is a good mental exercise for you to go back through the beginning of the problem and see if your answer actually worked. So I kind of made a little connection. This is your stairway to solving. Any of you Led Zeppelin fans, there you go. There's your shout out. So let's go to the next slide. So example 1, pretty basic, but I wanted to start off with not too easy of problems. 5x plus 15 plus 2 minus 2x equals 14. So we only really have one side of the equal sign to work with, which is kind of convenient. So what I've done is I've underlined in red the like terms and in blue the like terms. So the red have the variables, and you see up here you have 5x minus 2x. So I got that to be 3x, and 15 plus 2 is 17. So I've simplified that side of the equation. So now with 3x plus 17 equals 14, I need to make sure that I isolate my variable. I only have one variable now, x. Isolate means move the 17 to the other side with the 14. So you see in red, I've moved it, and whenever you move something across the equal sign to the other side, we're going to have to do the opposite operation. So addition is opposite of subtraction, and multiplication is opposite of division. So it works pretty hand in hand. And you'll see both of those throughout this lesson. So we subtracted it, and we get 14 minus 17 is negative 3 in black. So 3x equals negative 3. Again, we have to do the opposite. We're multiplying the x by a 3. That is why I divided by the red 3. So on both sides, I divide by 3. And when you do that, it comes out clean, and you get the negative 1. So opposite signs give us the negative, our x equals negative 1. If you go back and check your work, which you might want to pause the video and do right now, and see if it actually equals 14 when you plug in negative 1 for that x and negative 1 for that x. Maybe try that on your own right now. Number 2. Number 2 is a little different. I'll give you two ways to solve this one. It's 2/3 p equals negative 18. Now, the 2/3 kind of scares some of you, I'm sure, and some of you are like, okay, I know exactly how to approach this. But it is an awkward problem. So on the approach A, what I've decided was this. I said that, all right, P is being multiplied by 2/3. So if I see multiplication in this problem, then I'm going to divide to get the answer. And your calculators can really help you with this as well, but the concept of dividing when you see multiplication is where we're going with this. So as you notice, in the red, I divided both sides by the full fraction, 2/3. So it's kind of large. And I didn't mark them out, but when you divide 2/3 by 2/3, they cancel each other out. So you get 1. So I have 1p. And on the other side, negative 18 divided by 2/3, when you crunch those numbers out, you can actually get negative 27. There's a couple steps in between there. I could show you that if you want in class. So negative 27 is your answer. And once again, you can plug this back in for p and get your rightful answer. So you might want to check that right now and pause the video. The second approach is different. Maybe you're seeing 2/3 and you want to, instead of dividing, you want to multiply because you see a fraction. You can actually multiply by what we call the reciprocal. Reciprocal is just a fancy word for flipping the fraction over, but we're going to use reciprocal in math. It's part of our language. So you see 2/3, but in red I put 3/2. So I flipped it over, and I did the same thing on the right side with negative 18. Now, when you multiply reciprocals, you actually identify 1. So you're multiplying inverses together, and we might have talked to a couple of you in class about that. So you get p, and on the right side, you have negative 9 and 2 goes away. So the 2 goes into 18 9 times, and the 2 goes into 2 once. So you can do a little cancellation in the midst of all this, or you can use your calculator and solve it. And again, you get negative 27. So if you have any questions on either of these two, ask me in class, and we'll go over some of those. Do not mind at all doing that. Next slide. By the way, if my dog walks in during the video, I'm going to try to ignore him, but we may see if he wants to get in this. So he's not that good at math. Okay, last slide. The top problem, number 3, is a little bit more involved, and then we'll get to number 4 in a moment. So number 3, I put a little note on the top right that we'll see in a second. If you notice, here's the equal sign. We have a variable y and a variable y, and we have not seen a variable on each side of the equal sign yet until this moment now. So what I want to do is I'm looking at my problem, I'm analyzing it, and maybe you can answer right now what property you see and what I've kind of demonstrated with my arrows. Distributive, right. I heard a few of you say it in your head. Okay, so 53 plus 2 times 3y minus 1 equals 3 times y minus 2. And as you see, my 53 did not change, but 2 and 3 is 6y, and 2 and negative 1 is negative 2. 3 and y is 3y, and 3 and negative 2 is negative 6. So make sure you check your work in doing this problem. So on the second line, I have underlined on the left side the 53 and the negative 2, because I'm still simplifying both sides of the equation. So if you think back to your stairway to solving, simplify each side first. That's what we're going to do. 53 minus 2 is 51. My 6y has nobody to combine with, and 3y and negative 6 are totally separate terms. They're not like terms. So, on this line, I don't have any like terms on each side, so let's refer to the note. If you have variables on each side, this is very key, you might want to write this down. I want you to move the smaller or the lesser variable. So in this case, I have a 6, positive 6, and I have a positive 3. The positive 3 is lesser, so therefore I'm going to move it over with the bigger variable number. When I say move, I mean do the opposite operation. So it's a positive, I'm going to subtract 3y from both sides in red. All right, make sure you get that. That's important. So the next step, I have 51, and now I have 6 minus 3. I have 3 y's left on the left, and equals negative 6 now. That canceled out. 3 minus 3 is 0. So I'm getting to the answer. We're narrowing it down. So now we want to isolate. So we simplified, we moved. Now we're isolating our variable. So I see 3y. I want to leave it there. 51. I subtract 51. Over here I subtract 51 as well. You may need a calculator for that, it's a little different, but negative 6 minus 51 gives you negative 57. So I have 3y drops down in black equals negative 57 in black, and when you divide by the number in front of the variable, that should cancel out and give you just the y, and you get negative 19 on the other side. So negative 19 is our answer, and we'll need to go back and check that, and again, you can do that right now. I've already done this before I did the lesson, before I videoed, so you might want to check yourself and see if I'm right. Any questions on this problem? I think this is probably the hardest one so far. You could ask in class or individually, whatever you want. The last problem, number 4. It says the formula for surface area of a cone, so think of some sort of ice cream waffle cone, thing like that, is S equals pi r cursive L plus pi r squared. So the L stands for the slant height. So if you can imagine an ice cream cone upside down on its base, the slant height from the base, that circle base, to the point, that's the cursive L. And then R is the radius of the base. So if you lay it upside down, it's on its base. The radius from the center to the edge of that circle base is the little r. I want you to solve for L. So sometimes you may get a problem that doesn't have numbers, and you just need to rearrange it. So I don't want to know it in terms of surface area S. I want to know it in terms of the L, the slant height. I just took out a little bit of that pi. Okay, so we go over here. I rewrite my equation. That's my formula. And I need you to understand something. When we have touching symbols or variables, they are all considered one term. So I've underlined my L. There it is. So I'm going to leave that term alone right now. Let's go ahead and skip ahead to isolating the variable. Our variable is the cursive L. And so I look over here at this term, and it does not have a cursive L. So I'm going to move it to the other side of the equal sign along with the S, since that would be part of my isolation step. So I subtract pi r squared. I subtract the entire term from the right side, and I subtract that entire term from the left side. I think it's pretty obvious that the S and the pi r squared do not look alike. So when you subtract those, all you have to do is simply write them out like I have here in blue. So when you write them out, you have S minus pi r squared in line equals pi r L on the right side. So now it's kind of like the pi and the r are unnecessary for the L. We just want L. So what we do is we divide. Since they're being multiplied, remember touching means they're multiplying. And so we divide by pi r and divide by pi r. Well, on the right side, they cancel out. So we just end up with L in our answer. On the left side, you don't know what these values are. So therefore, we're just going to write it underneath. And you see in my answer, I didn't do anything special. I just wrote it down as it was. So if you get kind of confused by just symbols and variables, just understand that you might not be able to be as specific. You can just follow your steps, and you're done. So we'll revisit one more problem in class. If you have any question on number 4, because it's a little different, we'll talk about it. I think it could be a little confusing, but maybe some of you, through the explanation, were able to follow that. So in class, I'll give you your schedule on Monday. We'll go over this video, and we'll have some problems or a task to go over. So I hope you have a great weekend, and make sure you watch the video. And if you watch it and you know somebody else may not have, get in touch with them. So sorry it went a little long, but remember, always flip and don't flop.